In programming, iteration is a key feature of program flow that enables the repetition of specific blocks of code. It allows programmers to efficiently perform repetitive tasks without writing the same code multiple times. Iteration is implemented through loops, which repeat a set of instructions based on defined conditions. One common type of loop is the F4 loop, which is an example of a count-controlled loop. This means the loop is executed a predetermined number of times, making it highly efficient for tasks where the number of repetitions is known in advance. More complex scenarios can involve nested for loops, where one for loop operates inside another, enabling programs to tackle multidimensional problems. Both count-controlled loops and nested loops are governed by conditions, and they can be used to solve the same problems in different ways, depending on the requirements of the task. A for loop is a powerful and straightforward iteration structure that repeats a block of code a specific number of times. It is count-controlled because its execution depends on a counter variable, which is initialized to a starting value, incremented or decremented during each iteration, and compared against a final value. For example, in a program that needs to print the numbers from 1 to 10, a for loop can be used. The loop might begin with a counter variable, I, set to 1, and the condition would specify that the loop should run as long as I is less than or equal to 10. During each iteration, the loop executes the block of code to print the value of I, then increments I by 1. Once I exceeds 10, the condition is no longer met, and the loop terminates. This type of loop is not only efficient, but also ensures that the iterations are predictable and consistent. Nested for loops involve placing one for loop inside another, creating a structure where the inner loop runs completely for each iteration of the outer loop. This is particularly useful for solving problems that involve multiple dimensions or layers of repetition. For example, in a program designed to generate a multiplication table, a nested for loop might be used. The outer loop could iterate through the rows, representing the first number in each multiplication, while the inner loop iterates through the columns, representing the second number. During each iteration of the outer loop, the inner loop executes completely, calculating and displaying all the products for that row. This structure allows for the creation of complex outputs, such as tables, grids, or matrices, in a systematic and organized manner. Both for loops and nested for loops are controlled by conditions that dictate when the loops should start, continue, and stop. In a simple for loop, the condition is typically based on the value of the counter variable compared to a target value. In nested for loops, each loop has its own counter and condition, ensuring that the inner loop completes all its iterations before the outer loop progresses to the next step. These conditions are crucial for maintaining the logic and functionality of the loops, preventing infinite repetitions or unintended behaviors. For instance, a loop without a properly defined condition or an incorrect increment step could fail to terminate, causing the program to freeze or crash. Although both single for loops and nested for loops can often solve the same problem, they approach it in different ways. For example, consider a task that involves calculating the sum of all elements in a one-dimensional list of numbers. A single for loop can iterate through the list, adding each element to a running total. However, if the same task is applied to a two-dimensional grid of numbers, a nested for loop may be more appropriate, with the outer loop iterating through rows and the inner loop iterating through columns. Alternatively, even for a two-dimensional grid, a single for loop could be used with creative indexing, flattening the problem into a one-dimensional approach. The choice between these methods often depends on the complexity of the problem, the readability of the code, and the programmer's preference. Iteration through for loops and nested for loops is an essential technique for automating repetitive tasks and handling multidimensional data. Count-controlled loops ensure precision and efficiency, while nested loops provide the flexibility needed to solve more complex problems. Both structures rely on carefully defined conditions to function correctly and can often achieve the same goals using different approaches. Mastering these techniques is critical for writing clear, efficient and effective programs that can handle a wide range of computational challenges.